Hey everyone, we're going to take a look at the last one in section 4.4, number 15. I've got it on the screen because it's just checking the correct box or boxes. We're given this statement, let the function f be twice differentiable, be a twice differentiable function. So in other words, let it have first and second derivatives defined on some open interval from a to b. And then which of these statements regarding the second derivative and concavity are true? Okay, let's look at the first one. The graph of f is concave up if f double prime is positive on the interval from a to b. Well, if f double prime is positive on the interval from a to b, that means the first derivative must be increasing, right? Because the second derivative is the derivative of the first derivative. And so that means the derivative is increasing on the interval from a to b. If the derivative is increasing, then the function is concave up. So this is a true statement. So remember the connection. If the function f is concave up, the derivative must be increasing, which means the second derivative is positive. So be careful. Increasing and positive do not mean the same thing, but you've got to understand that relationship. And going to the second one here, if the function f is decreasing, what does that tell us? It means the first derivative is negative. Tells us nothing about the second derivative. Well, does this mean the graph of the function then is concave up? Well, no. Okay. The function is concave up if the uh, derivative is increasing, right? The function is concave up if the derivative is increasing. We just said that up here. So we would not check this one. This would be not true, right? If f is increasing, then the graph of f is concave up. That would be true. If f double prime of c, so the second derivative evaluated at some point c, we'll assume obviously c is in this interval from a to b. If f double prime of c is negative, then the graph of f has a local minimum at x equals c. Well, this is false. Now be careful. You should be thinking about the second derivative test. This is sort of where they're getting this from, but they're missing some information. First of all, f double prime of c being negative would mean the function is what? Concave down, right? Concave down, because if you're concave down, your derivative is decreasing and your second derivative is negative. But if you're concave down, think of that shape, right? Like a parabola opening downward. If the derivative is zero somewhere, you would have a local maximum, but you're never going to have a local minimum anywhere. Okay. So this is not true. Even if they had said instead f has a local maximum at x equals c, that still we couldn't say is true because what has to be true is that the derivative at c would have to be zero. That information is missing. So we got sort of two problems here. This is not true in general. Um, let's look at the fourth one. The concavity of a graph. Well, this is just saying any graph. I assume they're talking about this function in particular, but any graph changes at an inflection point. Well, that is true. I mean, that's the definition of a point of inflection is when we have a change in concavity. So be careful when you're checking, for instance, the second derivative. If the second derivative is zero, for instance, at a particular value in the interval, that doesn't necessarily mean we have an inflection point. We have to make sure that we have a change in concavity. Okay, the last one is the graph of f has a local maximum at x equals c if the second derivative of c is equal to zero. Well, this is not necessarily true because we need to know some more information. If the second derivative is zero, in fact, thinking about the second derivative test would be inconclusive about what's going on. Um, we would need to know something more, right? We would probably have to look at have some information about what's happening at the first derivative. So if the second derivative is zero, we could have a local max, we can have a local min, or we could have neither. Um, it just depends. We need some more information about the first derivative. So this is not necessarily true. Um, Now, if we knew the first derivative, sign check of that, we might be able to answer this question. So it looks like only these two, the first and the third, are true. Let's check and see if I know what I'm talking about. Okay, very good. So I can go on to the next question. Hopefully this is helpful for you. Um, if not, always please feel free to ask for help. Thanks.